Thank you so much for joining us for this edition of JMI TV. I am Andrew Zimmer, and our co-trainer here with us is Tim Roth from Yokogawa. And Tim's going to be doing most of the talking on the expertise, but I just wanted to set the stage for you guys. When you typically think of a tunable diode laser, you might be used to seeing a cross-duct analyzer, so basically two lasers on each side of a duct. But what if you only had to attach that laser to one side? And that's what we're here to talk about today, the TDLS8100, which is the same TDL technology, the tunable diode laser technology that we've all been using, but it's just a probe style laser this way. So what does this mean? Essentially, half the install cost, half the maintenance, and a lot more places you could install a tunable diode laser. Tim here is with Yokogawa, and he's the product expert. So we're going to take you through a few slides. I'm going to go ahead and transfer session control over to Tim. And Tim, go ahead and take it away.
Good morning, everyone. Let me go ahead and accept this. And I believe I'm in control right now. And thank you for the introduction, Andrew. What Andrew is referring to is actually, you can see the two different styles of TDLS analyzers. You can see the probe style, 3 of them. And on the bottom, you can actually see the actual TDLS8000, which has basically a laser located on one side and the receiver on the other side. So today we're going to do kind of a speed presentation here on the TDLS8100 and some of its advantages, and then we'll take questions afterwards. What is it? The TDLS8100 is basically a probe style analyzer. It mounts on a flange. That flange can be 2-inch, 3-inch, 4-inch. That doesn't really matter too much. The length of the probe actually comes in either a 0.7 meter, 1 meter, 2 or 2 meter probe. The whole purpose of it is to make a measurement of some very specific analytes, specifically the oxygen molecule or the CO molecule or the ammonia molecule or the HCl molecule. It's relatively limited compared to our TDLS8000, which has a number of other measurements that we can do with it. In the case of this analyzer, it can measure one analyte at a time, with the exception of the CO and methane laser. The whole purpose of this measurement is to make a measurement in situ, inside the process. And we're going to use the fact that different molecules will absorb a laser's energy at different frequencies. It basically gives you an analysis that is free from interferences. And that's one of the key benefits of this analyzer, is interference-free measurements. So as Andrew alluded to, instead of having 2 flanges to mount, we only have to mount 1. There's a couple of caveats we have to watch, and we'll hit on those here in a minute. I'm not going to go into the math or anything today like I normally do in a presentation or give you a lot of detail. Suffice to say that the whole measurement of TDLS is based on the fact that a molecule will absorb a laser's energy, and it absorbs it into its bonds, into the expanding and contraction, into the scissoring, into the motion of actually absorption of that energy at that specific frequency. More molecules in the way of the laser beam of oxygen or CO or methane, the higher the concentration. So you can kind of equate it to a molecule counter. More molecules, the more the absorption occurs. The more the absorption occurs, the higher the concentration of the analyte that we're looking for or looking at. Give you a range of frequencies. Oxygen absorbs at approximately 760 nanometers, whereas the CO molecule absorbs at approximately 2200 nanometers. Big difference there. We do not tune from 760 nanometers all the way to 2200 nanometers. Rather, it is very small tuning that's done right around those specific frequencies. Here's some of the caveats. It's a beautiful fact. Hey, if we only have to mount 1 flange, that means we only have to have access via manways onto one side of a process. So if I'm mounting this analyzer onto a stack, a duct, I only need access one side, and that's really, really helpful. But there are some limitations, and the main one that you're going to see is the process maximum temperature is 1,112 degrees Fahrenheit. So I'm not going to be able to put this in a process heater application where I measure across the radiant or the radiant to the convection section of a process heater where the temperature might be as high as 2,500 degrees Fahrenheit. In that case, I have to fall back onto my TDLS 8000. You can see it can handle some significant pressures. The reality is the measurement is actually occurring across a window that you see here. What happens is a laser is placed down in this area right here. It fires through a window down to what's referred to as a reflector. Fancy term, you guys, for it's a mirror. You notice the process flow. The process flow basically comes this direction against the rounded side of the probe. As it flows, basically it dumps whatever gas is to the inside and constantly is refreshing them and pushing them out. On the face of the analyzer, you have a small display that tells you what the process variable is. The transmission tells you if you have any alarms associated with it. So you're going to see the orientation of how this is mounted in relationship to the probe is going to become of importance. There's my fancy mirror, you guys, called a retroreflector. The beauty of this is it mounts onto the probe. When you receive a TDLS8100, it's already aligned. When you receive a TDLS8000, alignment of the two installed flanges, the opposing flanges, is critical. In that process of getting and making certain that that mounting is adequate to support the analyzer on both sides, it kind of goes away here. Basically, we still have to support weight, but we don't have to do an alignment of two different devices. There is a process window that the laser fires through. It's replaceable with 4 screws that basically are retentive screws. It's set up on a modular design, just like our TDLS 8000. Everything comes apart. It's replaceable as modules. A laser module can be ordered from our plant, and it can be replaced, and it's already calibrated, so it's pre-calibrated. As you can see, depending on if we're in a Class 1 Div 1 area or Class 1 Div 2, there may be an extra window associated with this analyzer. And by the way, the analyzer is only available as a general purpose analyzer or a Class 1 Div 1 analyzer. The operator interface, a very, very friendly operator interface that can display and handle up to 4 TDLS 8000 analyzers. So you can set it up in different quadrants and look at those analyzers. You can configure all 4 of those analyzers from this operator interface. And that's all it really is. Typically, the operator interface will be placed down at ground, down at grade. And then we communicate to the analyzer to the TDLS8100 via an Ethernet network. You get a lot of good information back on that operator interface. And oh, by the way, there is also an operator interface software package that emulates this exact HMI. And that is available at our website and is actually a free download. Installation. When you take a look at the installation of the 8100, we need to know what the direction of the flow of the hot gases are. And that will determine how we orientate the actual analyzer when it's mounted onto the probe itself. Not really designed, you could technically change directions out in the field, but it takes a little bit of work. So the preference is to know up front what direction of the 12 different possibilities that you see portrayed there. What direction is the flow? We need to specify that up front. Different lengths. The probe comes in either 0.7, a 1, a 1.5, or a 2 meter probe. The optical path length in reality, everyone, is really this distance from here to here, which is 500 millimeters, which is basically 1 meter. That's our optical path length. If I'm a 2-meter probe, all we do is we push that optical path length further out into the process. In other words, we don't get a longer optical path length by buying a 2-meter probe. We just get it further into the process. So depending on the duct size, the heater size, the stack size, we would choose these different length probes. Purging. There's also going to be purging associated with the TDLS8100, as we do with the TDLS8000. The preferred purge gases are always going to be nitrogen if I'm doing an oxygen measurement. If I'm doing a CO measurement or an ammonia measurement or CH4 measurement, we could use instrument air, clean, dry instrument air. The utility panel. Whenever one looks at a utility panel, this is set up to support an analyzer. 2 in this case. This is what's referred to as a dual utility panel. So it will have 2 sub-panels. And none of this is rocket science, you guys. You can actually build these panels up yourself. But what the important thing with purchasing them from Yokogawa, from JMI, is basically that it's pre-packaged. It's plug and play compatible. You don't have to issue a bunch of purchase orders to get a bunch of parts. So the purpose of the utility panel is, number 1, provide purges. Number 2, provide the power for the analyzer. The analyzer is powered by a 24-volt DC power supply. It's a 5-amp circuit. No, it is not loop powered. So each analyzer will have a power supply in it, as well as a power supply for the HMI and the Ethernet switch. Quoting, whenever we look at a TDLS 8100 or an 8000, there's always going to be a data sheet that we're going to ask you to complete. And that data sheet basically goes into some pretty good detail how the probe's going to get installed. But the critical ones are always going to be, what is the stream composition? What are the physical parameters that we're going to put the actual analyzer on? We need to know the stream composition to make sure that we choose the correct peak. Now, I didn't go into a lot of the math or the detail about what that peak is, but when we look at the peak, we're looking at a peak of oxygen around 760 nanometers. We want to make sure there's no interferences. And I'll say I don't do that. I actually have one of my application engineers look at that. And we basically let them look at your application sheet and say, number 1, can we do the application? In the case of the 8100, this is the temperature below 1,112 degrees. Is the pressure below? Are there any interfering gases associated with it? What is the dust load? One of the critical ones I need is if there's in a dusty environment, I need an indication of what is that particulate load in grams per meter cubed. The reason for that is that tells me how far I can throw the laser without blocking it totally. So one of the key critical ones. Applications. We see both the TDLS 8100 and the 8000 used in multiple different applications on boilers, process heater stacks. We see them used in thermal oxidizers. We see them a lot in limiting oxygen concentration. In other words, looking at a vent header to make sure there's no oxygen present in a vent. We look at vapor recovery units. We've done it in vinyl chloride monitors, excuse me. So there's a number of different applications that we can use this analyzer on. The probe style is specifically well suited for stack applications or duct applications, or even a vapor space above a tank type application. Key points. Just wrapping it up quickly, and we'll move on to any questions anyone has. It's a single flange design. I only need one process flange. it comes to you pre-aligned. I don't have to go through an alignment of two different flanges or a laser unit and what we call a sensor control unit. It's making the measurement in situ. I'm not removing the gas from the process. It reduces time and costs associated with consumables and routine maintenance. It's interference free. Oh, and by the way, it's SIL 2 rated straight out of the box with a single analyzer. Very important safety shutdown systems. That, everyone, it concludes this portion of my presentation. Welcome any questions anyone would have.